For people in the education field, student outcomes are the most important indicator of success. A research done by Barrett et al. Proved that classroom design has significant impact on learning outcomes. In this case study, we will be proposing a classroom layout design that can be used as teaching venue for undergraduate students and research laboratory for MS students. To give a background, the concept of active learning as a teaching pedagogy has been widely used in various practical fields of study, such as engineering. Engineering lends itself naturally to a more hands-on practical model of learning. In traditional classroom settings, classrooms are primarily lecture-based, and there isn't enough space available for tools and equipment integral to the application of engineering concepts. While it is important to provide information-rich education to students, it's also important to strike a balance between communicating information and letting students apply everything they have learned. Secondly, according to Fielder and Silverman, engineering students tend to be visual sensing, inductive, and active learners. To bridge this gap, technology-enabled active learning, or TEAL, helps in enhancing active learning in universities. Adding televisions or projectors in classrooms, as opposed to traditional blackboards, will largely help in the learning of students. In determining the ideal locations of a classroom and a laboratory, several factors may be considered, including accessibility for persons with disabilities, accessibility to necessary areas such as comfort rooms, and safety exits in cases of emergencies. In determining the ideal layout plans of a classroom and a laboratory, factors to take into account include the student population, the capability of the facilities in terms of the equipment it can hold, and the ergonomic factors of the facility, such as light, temperature, air quality, classroom flexibility, and chair characteristics. The general objectives in planning for a classroom and laboratory then would be to minimize the total cost and to maximize the learnings of students through providing an appropriate and conducive environment for active learning. We will now be discussing our general methodology in designing an ideal facilities planning classroom. First, the shape of the classroom will follow a rectangular form to maximize space utilization. Standards will be followed for the allowance of 50% of the occupied space and chair area of 0.42 meters by 0.4 meters. The first row of seats should be ideally a minimum of 9 feet from the front of the room. An 8-seater desk to accommodate the active learning principle will measure 1.8 meters by 1.2 meters. The instructor station will require 10 square feet. In a room with capacity ranging from 25 to 75 students, the whiteboard should also measure 20 feet wide and 4 feet high. It's also preferable to have no big windows as to avoid sunlight glares, so smaller windows will be installed at the top of the room to promote ventilation. To determine the size of the classroom, we'll be using a linear programming model, where n is the expected number of students in a class, and y is the number of tables. We'd then like to maximize z, which is the total area that will be occupied by the tables and chairs, with the following constraints. We have a space constraint and a desk constraint, and also a non-negativity constraint for n and y. Here is the graphical solution to the linear programming model. We can see that the highest integer point along the n equals 8y line is 32, 4, which means there are 4 tables for 32 people. This is the value we'll be applying to our methodology. The calculation for minimum space required for a classroom is as follows, where C sub d is the chair depth, T sub L is the table length, C sub W is the chair width, and T sub W is the table width. For our general methodology in designing an ideal facilities planning laboratory, we define N as the average number of MS students who will be using the lab per week. A rectangular shape for the room will also be used. 3 bookshelves will also be used to store relevant references. And 1 bag rack will be used to establish neatness and organization in the room. To accommodate n MS students conducting research, 5 over 3 times n desktop computers will be installed, where 5 over 3 is the factor for allowance. For consultations with advisors, 2n 4-seater consultation tables will be provided. And 1 10-seater table will also be provided for larger meetings with visiting professionals and guests. The calculation for minimum space required for a laboratory is as follows, where PC sub L is the computer length, PC sub W is the computer width, C sub D is the chair depth, DT sub L is the discussion table length, DT sub W is the discussion table width, TT sub L is the training table length, TT sub W is the training table width, S sub D is the shelf depth, and S sub L is the shelf length. In planning for material handling, doorways should ideally be located at the back of the classroom to ensure that students who are entering or exiting the space will not disrupt instruction. An exception for this would be in large classrooms or auditoriums where multiple doors may be required. Doors should also at least be 3 feet wide and 10 feet tall. For facility systems, the number of air conditioners can be determined by the total horsepower needed, which can be computed from the total area needed to be cooled, divided by the available horsepower per air conditioning unit. The number of fluorescent lamps can be determined by using the recommended minimum number of lux required for normal activities of 200 lux or lumen per square meters and the total area needed to be lit. The number of sprinklers and fire extinguishers will follow the building standards. Now we move on to the specific case at hand. We are given that there is an average of 30 students in an undergraduate facilities planning class, while there is an average of 3 graduate facilities planning students who will need to use the laboratory every week. Taking all these into account, the minimum required space for the research laboratory is then 29.4 square meters, and for the classroom is 51.77 square meters. The specific case restricts the space for each as follows. Comparing the numbers, we can see that the minimum required space is less than the available space. The case is also constrained by a budget of 3 million pesos, which will mainly be considered in the purchases needed for facility systems and equipment. Here is our proposed active learning classroom, utilizing large 8-seater tables to encourage group discussions. 2 doors are also recommended. For our proposed research laboratory layout, which will be connected to the classroom through this door, 6 consultation tables will be used for meetings with advisors. 5 desktop computers will be for research to be conducted by the students, and a larger discussion table will be for meetings with visitors or group discussions. Here are the summary of costs for classroom, totaling to 215,218 pesos and 96 centavos. Meanwhile, for the summary of costs for the laboratory, we have a total of 475,850 pesos. Adding the costs up, we can see that the cost is well within the 3 million peso budget. Thus, we have successfully planned the classroom and laboratory for IE students taking up facilities planning. Thank you for watching our video, and we hope you learned a lot. Have a great day ahead!